All right, we want to determine the sign of this permutation, which we will call alpha. Okay, so if n is odd, we're going to break this up into cases. Then alpha equals, well, let's write out what alpha would look like. We have 1n, 2n minus 1, then, of course, some dots. We'll leave the middle blank, and then minus 1 and 2, and 1. So what's it going to look like at the middle? So if n is odd, then you're going to have like an odd number of columns here, and so there's going to be one right down the middle where you kind of reflect on either side. So here we're going to have, let's see here, because if you count this 1 through n, this halfway point is going to be at n plus 1 over 2. Because let's see here, if we had 1, 2, 3, 4, 5, and then whatever at the bottom, you'd have this 3 is the middle point, and that's just, let's see here, 5 plus 1 divided by 2 is 6. You can verify for yourself that this is what it's going to look like in the middle. You're going to have this n plus 1 over 2 sends to n plus 1 over 2. And so what alpha is going to look like is it's going to be 1 and n to 1. That's going to be a cycle because 1 will go to n will go to 1. Same with 2 and n minus 1. And then all the way up to, let's see here. So here what we're going to do is that we're going to end up with this thing, like this column and this column. These together are going to form a cycle. And so what it's going to end up being is we're going to have n plus 1 over 2 minus 1 and n plus 1 over 2 plus 1. Okay, so now that we have that, I'm going to erase this picture. Because now we have a formula that we can work with. And so n alpha, this is the number of transpositions you can break it up into. This is n plus 1 over 2 minus 1, because you can count these going by the first thing here. We have 1, 2, and then you count all the way up to n plus 1 over 2 minus 1. And by the way, this is of course always going to be a whole number because n is odd, so n plus 1 is even, and so you can divide it by 2. So anyways, so this is this, which is, when is this? So we want to know the sign of this. So we want to know when n alpha is even and when n alpha is odd. So which is, so here, this is even. Come on, right, even if and only if n plus 1 over 2 is odd, right? Because that just differs from what we're looking for by a factor of 1. So n plus 1 over 2 is odd, which is if and only if n plus 1 over 2 equals 2k plus 1 for some k. And that is if and only if n plus 1 equals 4k plus 2. It's in if and only if n equals 4k plus 1 here. All right, for some k and z here. Okay, so that was a huge thing that we had to go through to figure out when this happens. So that's what happens here. So there's that. And then what's the next thing? I lost my place. And so what if n alpha is odd? Do the same thing. That's if and only if n plus 1 over 2 is even. That's if and only if n plus 1 over 2 equals 2k. That's if and only if n plus 1 equals 4k. That's if and only if n equals 4k minus 1 for some k in z. if n is even now, then we do basically the same thing. But first we have to write alpha. Then alpha is, we do the same thing, 1 through n, 2 through n minus 1. But here, what's going to happen if you look at it is you're going to end up with, like, say we have 1, 2, 3, 4. You're not going to have one thing in the middle here. That's fine. You're just going to end up with, when you divide it by 2, you're going to have this n over 2 here. Then you're going to have this n over 2 plus 1. Right? And so this is going to be 1 through n to the n minus 1. And then we're going to end up with n over 2 and n over 2 plus 1. That's actually wrong, different from what I have in my notes. So hopefully this will not completely break everything, but let's see what happens. And so, what does this mean? N alpha. Again, we can count this. This is just n over 2. So that's a little easier to work with. It's also completely different from what I have in my notes, so I'm going to stop using them. So this is this. So let's see here. N alpha is even if and only if. Let's see here. What does that mean? That means n over 2 equals 2k if and only if n equals 4k for some k in z. And alpha is odd if and only if n over 2 equals 2k plus 1, and only if n equals 4k plus 2. That's as far as we want, right? 4k plus 2 for some k in z. So let's see here. So let's see here. If n is odd, so that basically takes care of it. The sign will depend on whether n is odd or even. When n is odd, then it depends on whether basically what it comes down to is how you write. And I guess I didn't go further from this. It seems like there should be a simpler. Okay, so if we have, like, let's see here, we have like a 4k plus 1, 4k plus 2, 4k plus 3. So basically these are the different cases that we end up considering, right? Let's see here, we have the 4k plus 1 here. We have the 4k plus 2 here. We got the 4k here. 4k minus 1. Okay, well, we can write that as 4k plus 3, right? Because you just change k by a factor of 1, and the minus 1 becomes a plus 3. So anyways, we can write any natural number as, if it's not divisible by 4, then it's off by either 1, 2, or 3. So it's obvious that you can write any natural number in this way. So let's go back and review. Let's see here. So if it's 4k, then okay. Well, okay. Okay. Let's just start from the beginning. So even is 4k plus 1. So that's even. Odd goes to 4k plus 3. Okay, so this is even, and then odd. I guess that's a little interesting because you have It goes even, even, then odd, odd. It doesn't switch back and forth between the two. But anyways, so hence if let's see here, if n is congruent to k mod 4, then sine of alpha is 1. When, see here, when k is equal to 0 or k equals 1, and okay, we can get these out of the way now, and sine of alpha equals -1 when k equals 2 or k equals 3. So there we go. That's how you determine the sign of this permutation, and this completes the proof.